Hello and welcome to the Urenco experience. Why not join us on a tour of the facility to show you the processes that we conduct every day. The first place we're going to visit is the control room, and at Urenco we enrich uranium to provide fuel for nuclear power utilities. In the state-of-the-art control room, every aspect of the enrichment process is closely monitored by our experienced operators. This ensures that our world-leading centrifuge technology operates safely and efficiently 24 hours a day, 365 days a year. Let's take a look at the hot boxes and heating the UF6. The uranium in the form of UF6 reaches our enrichment facilities as a solid, which is stored securely in cylinders. In this area, the cylinders are heated up to turn the solid UF6 into a gas, so that it can be fed into our centrifuges and enriched. The cylinders are heated in hot boxes, which are like low-temperature industrial ovens. In this illustration, you can see the cylinder going into the hot box. The cylinders of UF6 are heated up to around 40 to 60 degrees C, or approximately 100 to 140 degrees F. At this temperature, the solid UF6 becomes a gas and hence now ready to be enriched. This is then fed into the Cascade Hall. Here is where the key part of the process takes place. A series of connected centrifuges is called a cascade. The Cascade Hall is made up of many cascades which work in parallel to each other, and every cascade is made up of individual centrifuges that spin at incredibly high speeds. Uranium which just passes through one centrifuge does not have the concentration of U-235. Therefore, the gas is passed from one centrifuge to another. As the centrifuge spins, the heavier 238 is pushed closer to the wall of the rotor, leaving the lighter U-235 to collect in the centre. The force that separates the isotopes is the same force that pushes you back in your seat on a roller coaster. The gas closest to the wall becomes depleted in U-235, while the gas nearest to the rotor conversely becomes enriched in U-235. The process continues through many more centrifuges in order to enrich the UF6 to a final concentration of around about 4%. So now let's take a look at the cool boxes where we solidify the gas. We cool the cylinders in cool boxes and the gaseous UF6 solidifies on the cold walls of the cylinder. When it's cooled, it returns to a solid state once again. Sampling, where we check the assay. We take samples of the UF6 so that we can test the quality and check the level of enrichment, the assay. This enables us to report the total uranium quantities and their U-235 assays to international industry regulators. The UF6 is liquefied by heating the cylinder for several hours in an autoclave. The autoclave and the cylinder within it are then tilted and a small quantity of the liquid UF6 is extracted into sample bottles attached. When the cylinder has cooled down sufficiently and the UF6 is solidified again, the autoclave is opened for the safe removal of the cylinder and samples. These samples are then taken to our on-site chemistry labs where the assay is tested. The weigh stations, because we account for every gram. We record the precise weights of incoming natural uranium and outgoing enriched uranium for a commercial accounting for our customers and to comply with international safeguards. At the weigh station, we record all incoming and outgoing cylinders. They're weighed to measure the amount of UF6 arriving and leaving our enrichment plants. We need to store the uranium. We store natural enriched and depleted uranium in cylinders securely on site, and we're committed to uranium stewardship. The depleted uranium has the potential for possible refeeding to extract more U-235, so we safely store the depleted uranium in internationally approved cylinders. We make full provision for the safe and complete decommissioning of our enrichment facilities and for the long-term treatment of depleted uranium materials. Finally, transportation. The final part of the process is to ensure that our product is safely and securely transported and delivered to our customers. We safely transport the cylinders of enriched uranium within licensed protective casings that meet stringent international standards. The enriched uranium will go to fuel fabrication facilities for conversion into fuel pellets and insertion into fuel rods. The fuel rods will ultimately be loaded into the core of a nuclear reactor to generate electricity that will be used by consumers around the world. Thank you for watching.